Hey, there we go. Well, I'm from the IET who actually made that video. So Nick never told me he was going to put that on, so yeah, follow that. The first thing I'd like to do is actually, one of the committees that I chair is the Northwest Joint Institutions Committee, which tries to pull together a lot of the institutions in the Northwest. And it must be about 9 months ago or more that Nick approached me saying he wants to put on an event in Manchester on a Saturday where he gets lots of people under 30 to come out early on a Saturday morning. Didn't think it was possible, but actually his work and the work of others has made it possible. It's the sort of event across the institutions we like to promote and support. So thanks to Nick and his team, and I know lots of people have worked hard on this. I'm the vice chair of one of the local institutions, which is the Institute of Engineering and Technology. And what I want to do today is give you my top tip on what you should, and a way you could approach engineering. And the top tip is that you should embrace change, because the only guarantee you have if you enter into a career in engineering is the future will be different. Now, that's not always been the case. Sometimes when I started in engineering, the main principal outlook in railway engineering, electrical engineering, was learn how to do the job and then do it the same for the next 30 years. That is no longer the case. Now, what I do as a business is I encourage collaborative research. So I encourage universities, small and big businesses, and what you might call end users to get together to try and solve some problems. And I do that in two ways. I use some ways to try and explain what that is, but also I'm networked, which is the thing you'll hear a lot today about institutions. I'm networked into industry bodies, research bodies. I sit on one of the committees of the US Transport Research Board, and I regularly work together with academic institutions and part of the professional institutions. So you try and bring all this experience together. But what we try to do is, that's kind of good. That little thermometer on the side there is something that NASA had come up with, a way of trying to work out whether things would fly or not many years ago, by starting with a basic idea and then moving through various methods of proving to the point where it may be safe to go in one of their rockets, although I've seen one of the later presentations. And as a methodology, probably as a good sound principle it works, but occasionally it might not, as we might see later. But another area I'm involved in is I don't just do the research. The key reason for me being involved in research as a private sector company, it be only a small one, is actually to try and get that research implemented. So a number of years ago I come up with some of the algorithms that are used in, if you look at Manchester, there's a big motorway that goes around the outside of it called the M60. It's now being dug up a lot, probably much to most of your frustration, to implement something called a smart motorway, which, would you believe, is the quick way of getting more capacity on a motorway. Although after 2 years of roadworks you might not believe that. But because I come up with some of the ideas of how to do that, I'm then able to take that technology and write documents for the US Department of Transport and here the New Jersey Department of Transport on how that could be implemented in another country. But also try and get across to the transport profession, in one of the things I've written for the World Roads Association, how to look at the future. Because if you're in transport technology, you're trying to deal with stuff that's dominated by consumer electronics, which has a lifetime of a year to 2 years, in a world that deploys stuff for 15, 20 years and has to get it to work. So I wrote a document about how they can approach that future. And I maybe want to share a couple of those insights into it. Because if I look at my career in engineering and in transport, the car on the left really was the height of road transport when I started my career in engineering. The Ford Cortina was the most popular car that was sold in the 1970s. And it was very much about facilitating people in this room of that era to become mobile and and then to become into a family car. I imagine do you mostly know what the car on the right is? It's the car that Google are hoping to produce, which you might think, oh, looks a bit of a joke car, but actually what people want from transport now has changed. And that car there is what you might call an autonomous vehicle, one that can drive itself. And in Nevada and in California, it has a license to drive on the roads. Not on its own, but with somebody sitting in the driving seat. But all they do is push a button to stop it if it all goes wrong. They don't steer it or do anything like that. So we have autonomous vehicles. However, being somebody who deals with trying to bring forward technology developments, I realised that when you come into something new, like autonomous vehicles or any new technologies, it goes through a cycle. And I don't know how many of you are familiar with this. This is these curves were what are called the Gartner Technology Hype Curves. And what they try and look at is, as you develop from the right-hand side, from the initial idea, from the left-hand side, from the initial ideas through to demonstrations, the actual hype behind things goes up and up and up. So this year I was at the Transport Research Board in the US, and we concluded, as Gartner have concluded, that at the end of 2015, autonomous vehicles are at the top of that curve. That in terms of what people believe they can do and what they can deliver, is probably now at the height of the hype. And what's going to happen soon is it's going to then slip down into the valley of reality as we try and deliver it. Now, there are reasons for that and why there is a lot of hype around innovation. And a lot of that is, if you say from academia, a lot of the approach, certainly when you're studying and then when you go into a PhD or postgraduate research, depending on whether you're in applied research or just general research, you may not have an idea of, if you solve the problem you're looking at, who might use it. So you're really looking at, you're part of what we would describe as a technology push from academia. You're putting new ideas out there and hoping somebody wants to buy them. Whereas where I'm coming from is I try to understand the technology, but I look at, well, what are the needs of the society? What are the social problems that we're trying to solve? And then through that, trying to bring the two together, we then can potentially come up with some form of solution. Now, a couple of the areas that I'm working on at the moment are, I've taken a bit of responsibility for one of the issues that is there anyone here from either Cumbria or North Lancashire? You may have experienced one of the issues that I'm now responsible for is climate change and floods. And the whole discussion around it is, at the moment, in terms of transport, is what should we do first? And how should we prepare ourselves? And what elements can we allow to either be flood or taken over by weather? And how can we recover quicker? And what's noticeable is the way we approach it now is we look at, let a disaster happen and then throw loads of money at it to put it right, hopefully, or not enough money to put it right. Whereas what we're thinking about is, well, actually, if we can do things better in advance, we might recover quicker. So it's a discussion that's going on, and the panel I chaired, we were looking at issues of, where they have deep snow, which happened in the US a few weeks ago, they actually decided to shut the transport networks down earlier than they needed to. But it meant they opened them sooner than they would have done if they hadn't shut them down. But I'm also looking at another issue, which it's an unusual way to present it, but that is a map of the air quality management zones in Manchester. And if anyone's familiar with Manchester, you'll notice that all those blue areas sort of mirror the major road network. So from that, possibly you might conclude that air quality problems are transport related. And there's a couple of reasons for that. One of them has something to do with a certain company called Volkswagen. I went to a fascinating talk where the US Environmental Protection Agency actually went through how they found the defeat devices in Volkswagens. But it meant that some of those cars were emitting 4, 5, 6 times as much noxious pollution than they said they were, or should have been. But other bits of it is that we need to manage the traffic better. And one of the projects I have is starting to look at, well, if we're able to manage transport in a different way, namely, if we're managing to talk to the vehicles directly from a central system, we can then improve their environmental performance. And in the US, they've just done this as part of a collaborative project with the EU. And they've managed to reduce emissions by 20% by just merely having a better interaction between the traffic light system and the vehicles by connecting the two together. So you reduce emissions by 20%. The issue I'm trying to look at, though, is I don't know if you're aware are any aware what the one on the left is? Now that is the company that Google have signed an agreement with to start producing cars. Now if you look at it, you might think that looks like a Ford. Well, actually that is the Ford autonomous vehicle that's going to be launched soon. And the collaboration between Google and Ford is really to try and turn a company that's got a lot of experience in autonomous vehicles, namely Google, with a company that's got a lot of experience of making and selling cars, to try and see where you can bring the two together. But the thing I'm involved in is, well, if you get a lot of those on the road, how do you manage the transport differently? And we start to try and work out how the technologies produce something different. The other area I'm looking at, which is more to do with the global issue, how would we reduce the carbon dioxide emissions from transport? And one of the ways that we're thinking of doing that is through electrification of transport. Now, at the moment, electric vehicles is the fastest growing sector of the car market. Last year, the sales grew by 150% in the UK, and they're set to grow by a similar amount this year. So while you might not see many of them at the moment, at the current rate of growth, there should be over 1 million of them by early in the 2020s. So actually it may be that electric vehicles take over. But the importance of those two graphs, even if you can't see them, is how many of you picked up on an announcement this week about mobile phones, that potentially, with a mobile phone, potentially rather than charging it once a day, you would charge it once a week? Did any of you hear about that? Yeah. Good to see people are keeping up. It's just that technology is the same technology which is that bottom blue line on the left-hand graph, which is if we have fuel cell vehicles, which was the technology they were talking about for mobile phones, potentially you could have electric cars that you charge once a week, not once a day, and they have ranges of 400-500 miles. And the other graph that seems to be going down and converging to a very low thing is if we implement them, actually the cost of the vehicles and the cost per mile would be less than the cost of petrol cars. So potentially you've got this huge fleet of electric vehicles that drive just like normal cars, however they might be autonomous. The challenge that I've got on one of my projects is, say that happened, well, where would we get the energy from? And could we use those as mobile batteries to actually shore up the energy grid, to try and integrate different sectors, which is another challenge I'm looking at. But maybe something, if you're doing cutting edge research in the university, one of the things I often do when I start working with the university is start to ask them, well, who would be the innovators and the early adopters? And this is a standard approach about what we call the diffusions of innovation. So you get people who, whatever Apple bring out, they would buy it. It's not just the Apple brand, but they generally are the innovators who just go, right, let's have the next Apple or the latest this or the latest that. Now that's a fairly set proportion of the market, but actually if we want to transform things, we've got to work out how they then disseminate that out to encourage other people to buy things and encourage innovations to go forward. Because the autonomous vehicles actually in the UK are already here. There might be some things from some of the more military-minded people who talk about military autonomous vehicles, which is different. But that one on the right is an autonomous vehicle that runs around Greenwich. So there isn't a driver, it just takes you from one place to another, and there's nobody driving it. So it is autonomously moving around Greenwich. It's noticeable that Land Rover have just been awarded a £10 million grant to enhance that sort of technology and start to use it to turn it into more production type models. But the thing that's worth noticing is that to get to the point of having a fully autonomous vehicle, you build in lots of little different things that go towards it. So there might be some of you who've got cars that park themselves now. The next step up from that is a lot of companies are launching cars that can park themselves in a car park themselves. So drop you off by the front of the supermarket and it goes and parks in the supermarket car park for you. And then when you've done your shopping, you do an app on your iPhone and it comes and picks you up from the front of the supermarket. It's all part of that autonomous or semi-autonomous vehicles. So it means that if I go back to where I started, Ford Cortinas, we're now going to have autonomous vehicles within the lifetime of your engineering careers. The main vehicles are going to be autonomous things that look like we're not sure. They might look like the Ford car, they might look like the Google car, but they're going to move around in a very different way than the vehicles at the moment. And when you think about if machines are moving around autonomously, you then have to start to think about, well, how does that affect the public perception of them? And a lot of the things I do when I'm taking forward cutting-edge research is we try to look at what the attitudes are within society. And the attitudes towards things like robots, things like mechanical devices have changed greatly in the last 40 years. So there are some things that are completely accepted and there's some things that we're very much more nervous about. So when I started in a career in engineering, it's very much in the right-hand side stuff when people had just gone through the space race and everyone's thinking about, by the end of my career, I'll be living in a house on the moon or on Mars. And that was the popular culture, not just within science fiction, but within a broader society. If you look at the way, say, robots were dealt with last year, there was a Channel 4 Channel 4 drama series, which was actually their biggest ever in terms of viewing figures, drama series called Humans, where they tried to present robots as things that look like people. So the robots were played by actors. And if anyone saw it, it was a very eerie sort of presentation. I'm sure they're going to bring it back for another series. However, why that's important, and you may have picked up on the fact that Manchester is the national city that was picked for a demonstration project for the Internet of Things, which will be starting next month. And Manchester University is one of the partners, as well as lots of others. But we're doing that because, if you look at the graph on the left, there's now more things that are connected than there are people in the world. And what we're trying to do, looking at the graph on the right, is join these devices together and mix the information in different ways to try and produce things that go across transport, energy and other sectors. Which brings me nicely to talk about how the institutions then fit in. I mentioned previously the Joint Institutions Group. Now those are the members that are currently part of the Joint Institutions Group in the North West. And maybe we could have a show of hands at how many people are members of those, any one of those groups? So that's okay. Well, I will introduce myself as the chair of the North West, and if you want to know any more about it, I'm happy to tell you more about it. Because actually, we're trying to set up a very active young members section of it to try and get some cross activities between the various institutions, as well as collaborating with the Manchester City of Science. But I'm also here to talk about the IET, which is the Institute of Engineering and Technology. And if you go to our stand, we can talk about the visions and the values. But actually, what I want to talk about is what it's for and what might interest you. Because I think I've been a member of it for nearly 30 years. I joined it when it was the Society of Electronic and Radio Technicians as a engineering technician member, and I've worked my way through to now being a chartered engineer, and the organisation has grown and merged and become the Institute of Incorporated Engineers, and now when it joined with the Institute of Electrical Engineers, the Institute of Engineering and Technology, but now has 163,000 members across the world. But more importantly, it has ways of connecting its members with the 163,000 members across the world when you start to work out what it is you want to do. If you're academically minded, there's lots of opportunities to present papers at conferences. If you're academically minded and you want to get some research out there, there's 195,000 technical papers you might be able to draw on. But we're also involved in lots of technical networks, which, to give you a sense, because there's lots of other institutions are going to present, we have 5 key areas of engineering: energy, transport, built environment, design and production, which is about manufacturing, and information and communications. Now, if you're involved in one of those, you might want to consider being part of the IET. Or if you're like me, I'm involved in all 5, it's probably one of the organisations to be part of. But it's not just this megalithic 163,000 international institution. Locally, within Manchester, we have a very active branch that puts on events around energy, transport, multi-technical. I know the IET Young Professionals have been heavily involved in organising this event. So we work with other institutions. The chair of it's currently on an event today for the young members on women in engineering, to try and get more women into engineering. And we have a retired members section for people like me when I get pensioned off, that we can still play a proper role. And there's a few things coming up where we're trying to involve more people in events around transport, or we have a very big Turing lecture, which you take information about, where we're presenting things about the internet coming up in the next couple of months. So I suppose what I've tried to do is give you a snapshot of, if you're going into engineering, it will be different than what it was when you start, when you finish. And the best thing to do is actually work out who you need to work with and who to join up with. And the best way to do that is to try and, at this stage in your career, broadly go outwards and reach out to lots of things and then pull the threads together. But that's probably all I want to say. So I don't know, there's probably 5 minutes if anyone wants to ask any questions about any of the technical stuff or anything about the IET. Yes, you said.
What work is Google and Ford doing into the security of autonomous vehicles? Because currently they're not overly difficult to hack once you know how to do it.
So they are doing a lot, and in fact one of the big issues that I was discussing at the Transport Research Board was the whole issue of cyber security. And I think they've realised when they started to turn cars from being mechanical devices into electronic devices, so there's no physical connection between the driving wheel and the wheels. It's done electronically, that it is possible to hack into it. And I know the projects that are being demonstrated now and the whole connected vehicle program is to try and work out how to stop people hacking into it, but also how to keep it connected, because it is a challenge, because we want the vehicles to talk to each other, because that's the huge benefit of having autonomous vehicles and connected vehicles, but we don't want malicious attacks that starts them, as you've probably seen the video of somebody driving a car off into a river where somebody's hacked into the car. So they're doing a lot, and I think that's why in some respects the expertise in terms of technical cyber security that Google have is now being combined with the automotive expertise that the likes of Ford have. But it's certainly an area where anyone who's got expertise in that, there's a good career for you for a while. Anyone else? Got maybe 1, 2? Yes, you sir.
How would you say that Tesla fits into the model with Google and Ford? Because they've currently got autonomous vehicles out. And on a second point that I'd like you to answer would be their battery technology that they're willing to come out with. Because you're saying the ability to store battery and energy within homes and off the grid would have an effect between all of this.
Yeah, Tesla are fascinating in this front because they make high-end market products, and their approach to things is to produce something new in a different way and then try and value engineer down the costs. So they have already, they're going to bring out autonomous vehicles. One of my projects, we're working with the people who are with Tesla on home battery storage systems, and certainly that approach of using a vehicle as a mobile storage system to balance the grid is something that Tesla are very interested in and have teamed up with others to do that. So in some respects Tesla are never going to become a mass market vehicle because that's not what they do, but they are always going to be at the cutting edge of trying to say that don't tell us that you can't do it, because we're going to solve that and make sure you can do it. But at the meeting I was at in the US, we went through a whole list of what the main car companies are doing in terms of autonomous vehicles in the next 5 years, and they're all doing it. They're all moving in that direction. They've all got electric vehicles, and they're all moving into a different form of automotive space. So maybe, yes, you.
What would you say the biggest barrier is to autonomous vehicle development?
The biggest barrier?
Yeah.
I think, if I was to be honest, it is really trying to overcome the way it drives at the moment. And there's the project that's going on in Greenwich with Land Rover are trying to get autonomous vehicles to drive the way people do. So trying to have all the safety benefits, but not drive like a granddad. Because that is the way they drive at the moment. They are incredibly safe, but when they come to roundabouts, or in America they have a lot of four-way stops, they're very tentative. They don't edge out. So they're very tentative drivers. So to actually get them to normally fit in to the rest of the fleet, I mean, you can deploy a lot in a short space of time. But it's the interaction between autonomous and non-autonomous is the key issue. Yeah, just one up with that, yeah?
How do you manage the balance between the change in infrastructure over from how we have it now to a networked, autonomous network, whilst still factoring in human decision making of other drivers? So if 20,000 people still want to drive manually, how do you balance that with the networked cars?
Now, I wrote quite a bit of that on the document I did for the World Roads Association. And one of the issues they have is around signage, would you believe? Because if all the vehicles are autonomous, you don't need road signs. You don't even need stoplights. They work it all out without visual clues. But there's a very strong, now, vintage car fraternity. And people who just like driving old cars, and they'll always be there. So what we've got to try and work out is how to get an autonomous vehicle or semi-autonomous vehicle on the same network as the non-autonomous ones. And I think in the US they're thinking of having separate lanes, which they have, say, for toll roads at the moment, but we could look at similar things in the UK. So it's that integration between the old and the new, before you get everything that's new and you've got some of the old. So I have a final question for everyone on the floor. And there's not a prize here, but I'd be interested to see how anyone can guess. Given all of that, I sit on a US Transport Research Board where we had a massive discussion about climate change and things. What do you think they would use as the front page article on their latest research thing? Because this relates to one of the next presentations. Any guesses? What they think, what's the key issue to discuss this month? Because I think if you're an engineer, this could be quite a fascinating topic. It is, yeah?
The Hyperloop technology that's being developed.
It is actually commercial spaceports and what we need to do to bring them forward. So, discuss. Thank you.